Hey, Rani here. Shall we make a game? Yeah. Right. So last time what we were working on was we were going to do this final bit here where it constrains a point in space to within a triangle. We'd gathered all the information that we need, so things like the exit normals and the kind of tangents used for kind of like plane intersections. And we worked out what the decision tree was going to be, and that's about as far as we got. So let's make this happen. Let's make it happen. What was I going to do again? Just kidding. Okay, so first of all, we need to calculate the distance to the AB plane. So that's as simple as that's a dot product, isn't it? Yes, it is. And it's going to be the AB normal, the abnormal. I think I've made that joke at least 15 times. And it's also going to require the difference between one of the points on that edge and the point we're testing against. So, yeah. And I think we've got a vector subtract, do we? Yeah, we do. Okay, so we can use that. And yeah, so we're using our point and then we're subtracting from that B, and that should give us our distance from AB. Okay, there we go. So we're over that edge, so now we project the point onto that line, so we multiply by a scalar, and then we multiply the AB normal by how far we are over the line, and we have 3 x's, and we're going to have a nice little multiplied normal here. And I think I'm just going to make a difference variable, as we're not going to reuse this once we've used it once. And then we subtract from the point, we subtract the multiplied normal, which should give us a point on that plane. Now, as a consequence of that, oh wait, this is complaining about something. What's it talking about? Oh, I haven't written an output. Okay, so the next thing we need to do is, hang on, get the distance on to BC. So this is going to be very, very, very similar. It's basically going to be getting a new point, and oh, I'm interested if there's actually a way I could have done this faster. Anyway. At that point, we have a distance to BC, and at this point, we know that we're over 2 edges, so what we can do now, I should really get Sprite up and start drawing what I'm doing so that I can explain it and also visualize it for my own benefit. So, yeah, so we have triangle here, we have A, B, and we have C. So, yeah, we're over this edge, we're over AB. So then we project our point onto AB, but in the process of doing so, say if it's here, it actually ends up behind BC. At which point we need to put it in this corner, but it's actually a 3D space, so we need to put it in this vertex, and then along kind of like the sort of like, yeah, this plane, the intersection line. So we do this again, which is where we basically project it onto, oh no wait, no we actually don't, What we do instead is we calculate the difference between that and that, and we dot product it along the what do we call these? These had a ridiculous name, didn't they? Yes, the edge exit intersection normals. Yeah, that's what we're going to do. And then Then we're going to multiply that. And we're also going to that was IE, now it's IE. We're also going to clamp it to 0 so it can't go underneath the surface. Okay. And I put this in the wrong place because I'm dumb. Okay, so at that point, we now have the kind of vector we need to add to B to get the place we want to be. So I think I've got a add vector vector. Yep, I do. So add B to that, which should give us our resulting point. Simple. Sorry. Only took an absolute mountain of... oh, hang on. No, I only took an absolute mountain of vector math to figure that out. Okay, so we're over AB and we find that we're intersecting with CA, so we actually have to use A, and A. And we also need a bit more math in here. That should... I need to bring in A here. That should... Oh yeah, I need to define this at some point. Let me just double check all this. I don't see anything obviously wrong. Doesn't mean much, but I don't see anything obviously wrong. And then next up we need to calculate distance to the surface, which is dead easy to do. So it's distance to surface again. We're taking this difference, which is the difference to point B. Yep, that's good. So we can use the surface normal. And it's less than 0. Okay, at that point, hang on, we'll be looking, say that we're looking along a triangle, right? The camera's kind of at this corner, we're looking at it that way. At this point, we're over A and B. We project onto this plane and we end up under the surface. So we're somewhere along this line. And I think we had those coefficient things. Yes, we did. Yeah. So now we get our point along the line. Okay. And that will actually give us the inverse of it. So we need to recalculate the difference up here. Oh wait, we already have it, It's already from A, so that actually kind of works out. So yeah, at that point we have distance along AB. We can then multiply that up and add it just like this. And I think we have a handy... Yes, we do. Ah, wait, it's not actually multiply, it's actually a progress along AB. So what we should be able to do is, I think we've got a linear interpolate. Yeah, there we go. So we're going from A, we're going to B, and progress along AB, 3 axes, and we output to the point. And we are also just going to want to clamp this down so it doesn't go off the ends if it happens to. Okay, now we're assuming that works. That wasn't actually that rough. That didn't take super long. It probably doesn't work, if you'll excuse my confidence, but that wasn't as hard to write as I thought. Oh god, there's a lot of these. Okay. So now we're going to copy and paste and introduce a whole bunch of bugs. Or maybe I don't. Maybe I Yeah, I'm not going to do that actually. So we've got the difference to B, so now we can use the BC normal to get the distance to BC. Okay, so now we know we're over BC, so we project onto BC. It's as simple as this. And then we subtract, yeah, so yeah, that's good. None of that needs to change. And then we're on our way to AB. So we're actually going to use the point A there rather than point, because our point A is the one that's shared with everything. Okay. So we've crossed, hang on, let me just uncryptify this a bit. So we know we've crossed this line, we've projected onto it, and now we're checking whether it's now crossing either of these two lines because they're not necessarily parallel. I mean, it is actually possible to project off one and end up alongside of another one. Here we've got AB normal, and we then get the distance to the surface along, hang on, BC, AB, That's actually B that we want, not A. Okay, intersection of BC and AB is point B, which is good. Distance B, 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 all B's, all happy with that. Okay, next up. We've got one more to do, which is distance at CA. So we're going to need a fresh difference for that. So we are getting, hang on, just thinking about this, and yes, it does hurt, okay. So the common here is C, we use that, and we're definitely at point C. Okay, that's good. And then finally, we are calculating the distance to the surface as our final case. And what do we have here? So our difference is to point C. Progress along CA, dead easy, all good. That should work. We need to replicate the structure down here. There's almost certainly like big mistakes in this somewhere. We'll find them eventually. Okay. Now we need to project onto CA. Calculate the distance to CA, that's the next one. We're going to have to calculate a new sort of starting point. So yeah, it looks like A would be a good starting point for these two. What's the difference calculated? There it is. Okay, now we know, let's just get this drawing back up. So we're now looking over this. So we are calculating how far we are from that. We then, it's easy, just project onto that surface. And then we're going to take another one, which is going to be point B by the looks of it. Yeah, because these are both point B, so we can use this difference for both of them. And that's easy. Okay, that's good. I have to do a distance calculation here. I might rename this difference just so it's clearer where it's coming from. just need the distance to the surface here. This one's dead easy, so we can stick this one in straight in here. Surface normal difference, and we are at, or what's the difference here? That is point B, so let's check here. Run this CA, so that's actually wrong. No, that is right. That is right. I think. Hang on. No, it's not. It needs to be point C, I think. Yeah, that'll do. We've got progress on CA. I think C. Just double check this one. Is this one right? So, no, this is wrong. We did this wrong. Oh, okay. Okay, we're catching bugs. That's good. That's good. That's good. It's actually the progress along BC we're checking here, not progress along CA. And let me check that the difference here is B. No, it needs to be along. No, hang on, that is right. Oh god, I'm talking around in circles. I don't know what I'm talking about anymore. Yep, I'm getting confused. How great. Okay, so at this point we know we're underneath the surface and we can use the distance to the surface, multiply it by that, surface normal. We've now projected the point onto the surface and now we can start comparing the point to the various edges, and yeah, that should be good. Let's just calculate our surface distance here. So at this point, what is going to be in our difference variable? It's going to be point A. That's fine. And we actually want to add that vector, not subtract it, as we're pushing it up to the surface rather than pulling it back from the surface, so that makes sense. Okay, so now we've got a distance to AB and distance to BC that's wrong. Oh, this could get confusing. So these need to be from surface, just to make it clear that we're working with a different quantity here. Okay, so now we calculate. Yeah, we need to take the, that's the one, yeah. We need to calculate a fresh difference and then calculate the distance to each surface. Man, this is horrendous and I'm here for it. And then we're just going to need one more difference here, which is CA. And testing this is going to be a challenge. So many branches here, there's no way I'm going to hit them all, practically speaking. We'll just give it a bit of a fuzz test and see what it does. Okay, so at this point, we know we're over the edge, so we, there's a question, do I ever need to, I realize I might have made a mistake here in like trying to skip a step. So I've got this kind of edge of the triangle and I've got corner of the triangle there. And let's say that, you know, the point is over this edge. So we project it and then we end up underneath the ground. What I'm wondering here is it possible we're going to end up in with a bit of bias or something because we're not considering all three, we're not projecting onto all three planes. But again, we're projecting them in an order, so I don't think this is ever going to be perfect. It just needs to be sort of good enough. Okay, so we have point B here, so we have an inverse progress along AB. Let's call that progress along BA, because that's basically what it is. And then we linearly interpolate to calculate where we end up on that line. And we're starting from, we're going from B to A, using that progress. Dead easy. If this works first time, I'm not even gonna know. Something's definitely wrong if this works first time. Is that all the branches covered? Oh, not quite, not quite. We missed a couple there. We'll figure those out in a second. Okay, so we're over edge CA and then we detect we're over AB, which means that we're looking to project along intersectional A and okay, that should be good. Okay, that should be good. And then we just need to do something similar here. Don't need to do subtraction anymore. So we're going to be on edge intersection normal. I think this is, oh, this is C. This needs to be C. Okay. C, he said typing B for some reason. Okay, so CA, AB is going to be A, CA, BC is going to be C, C, C. Okay, good, 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 good. All right. So a few things left to kind of sort out here, just these kind of variables that are currently undefined. That shouldn't take long. And then we get to see how this code breaks and spend like 3 streams trying to figure out what on earth we did wrong. It's the edge intersection normals, isn't it? Yeah, that's the one. Just gonna get all these compile errors cleared up before we try and do any renaming, because I think that gives it the best chance of actually working. Okay, that's all the compile errors fixed. So now we can rename these to be a bit more in line with what's actually in the triangle. Are you kidding? Oh, fine, I'll leave it named, though it's currently named, as terrible as it looks. Okay, where are we calling this from? Because I might just... yeah, I'm just going to temporarily comment all of this out, like all of it. And then I'm just going to make it call that constrain function, just so we can get an idea of how it looks. Okay, let's see what that does. Oh, didn't like something. It didn't like something. What have we? Oh, we've done something very wrong very often. What are you saying? Oh, it's because I've declared this as a constant and I'm not using it like one. Oops. This is going to have the same issue. As is that. As is that. My God, I'm not looking forward to debugging this. Ah! Oh yeah, then we actually need to return a value, don't we? What else is this talking about? Ah, I've still got a const there. Okay, all right, okay. Come on, let's go. Well, it built. Don't think it works, given I don't see a line anywhere. Oh no. Okay, so I think I have the advanced function as the one that has all the kind of complex logic on it, right? Okay, so step one, let's just check that this is working correctly. You know, that, say, copying the vector kind of works at all. That's fine, nobody cares, C compiler. Oh, that's interesting, that's not working. Why not? Oh, we're not actually drawing it on the screen, I don't think. That's weird. Well, that kind of explains that. This should draw one line that goes from white to green. There we go. Or vice versa. And now we should be able to see what happens when we run this code. Okay, that looks like it hasn't quite worked maybe, although maybe it has. Because, hang on, let me open up Blender and we'll have a look at the mesh. Because thank you for just opening a random file, Blender. Right, so it started from like here. Let's pull this across here so I can see what's going on. It started like here and it's trying to get to here. And it's hit this edge, it's kind of projected along it, or it's like done sliding collision along it. Huh. Just thinking about it, like, is that technically wrong? Because technically it sort of hasn't found the closest point on that sort of, you know, prism, but it has found a valid point. And I'm just going to check, is it possible it might have actually hit the edge of this corner as well? Okay, so what we're going to do is we're going to destroy every polygon except that one. We've destroyed all the polygons. I am the great polygon reaper. And I'm just going to do a build. And there we go. So now we have just our one triangle. And now we're going to bring this sort of code back in to get an idea of, well, to kind of like sort of sweep over a point in 3D space. And that should give us a clear indication of whether it's generally working. As you can see, it's kind of, yep, it's kind of working. So the next thing I'm going to do is I'm just going to get the center point of this, which is this, and this. Just so it kind of orbits around it and we get some useful kind of feedback. rather than it just basically like floating out in space. Okay, it did something weird then, and also it's currently sticking through the floor, I think, so that's not quite worked. Right, so this definitely has bugs. It's generally doing what I expect, but then also just not quite. Yeah, I don't know what it's doing right now, but that doesn't look right, does it? Let's just have another quick look and see if we can figure out which edges it's sticking through when it goes a bit wrong. Now I'm curious, is that in the floor right now? It's kind of hard to tell. This is tricky, isn't it? That looks like it's jumping back to the wrong corner. I might have mixed up one of my, so that's vertex C is going to vertex B instead. Let's see. So, if you'll pardon the pun, it's going to B rather than C. Okay, now we just start scrolling from top to bottom and seeing if we can spot anything untoward, maybe not the best word, but kind of like obviously wrong. There's probably a much better way of doing this if I was more of a math head. Okay, so we get the distance between this point we're testing and vertex B. We're then doing a dot product with AB, and then we're checking whether we're over the edge. Okay, and if we are multiplying the normal with how far over we are to get multiplied normal, and then we're subtracting that from the point to push it back onto the plane. We are then getting a fresh vector from B, and we're getting the distance. We're doing the same thing pretty much, just taking a dot product with the BC normal. If we're over, then we know at that point we are over vertex B. So we already have the difference to B. And at that point we can do a dot product with that normal, and we can then multiply it by the distance of the surface. We are limiting it so it can't go below 0, so we're always on the surface or above it. Okay, that's fair enough, and then we're adding that to B. So that looks right. Let's fold that up because we're pretty sure it's right. Okay, otherwise, right, so we know we're over side AB, and we're then getting the distance. We're getting the difference between the point in A, and then we're getting the distance past the CA plane. So if we're over it, then at that point we're at vertex A. That's correct. We are getting the distance to the surface at that point, and yeah, that looks right. Otherwise, so that looks right. Fold that one up. We are getting the distance to the surface from, where are we here? From point B. And if the progress along AB is just thinking a bit about whether I've made a wrong assumption or not here. So yeah, the progress along AB is we have the distance between. Oh, hang on. We've got the difference between the point and A. So what we actually have here is the progress along Yeah, we have the progress along AB because it's using the same coefficient. Okay, and then we're linearly interpolating from one to the other. Okay, that should be working. So that looks fine to me. Okay, next up. So we know we're not over AB, so we're getting the distance to BC and we are using point B. Okay. So again, using the BC normal, we're checking if we're over it. If we are, stop popping things up with a sheet of code that's not really helping me understand my code. We're using the distance we're over it, multiplied by the normal to get multiplied by the normal. We're then subtracting that from the point to project our point onto the plane. We're then again comparing to B because the point has moved. And then we're getting the distance to AB. And if we're over A, at that point, we are BC and AB, meaning that we're over vertex B. So it's B, B, B. That's good. That all makes sense. Fold that one up. Otherwise, we need to check our distance to CA because we're over BC. We're checking CA now. So again, C and C, that looks good. So at this point, if we're over that edge, we know that we are over vertex C because it's C and C. And then we're getting the distance to the surface. Yeah, so that should work. That looks fine to me. And then as a final case, we're starting from C, using the surface normal, we're getting distance to C. Now, we've got the difference to C here. So what we actually have is, this is wrong. This is wrong. That should actually be that. Okay, that's one potential mystery solved. Let's just see how it looks with that fixed, as that might fix some of our weirder issues. Like I'm anticipating this fixing the problem where it jumps into that corner. That one's still a bit weird, but it seems to be behaving itself a bit more now. Okay, that's good. Come on. Nope, 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 it's still misbehaving. Damn it. Okay, let's carry on, see if we can spot any more obvious, obvious bugs. So let's fold that up. So now we're getting the difference between the point we're sampling and vertex A. And then we're using that to figure out whether we're over edge CA. Okay, and if we are, we're multiplying how far over we are by the direction in which we're going over, and then subtracting that from the point to project it onto the plane. Nice and simple. We're then taking that point and we're comparing it to point B, and we're using that to compare to normal AB. If we're over that face, so we're over CA and AB, we're over vertex A. So again, calculate the difference to there, and then we're doing a dot product with that intersection normal. Yep, that's good. So now we've got distance to the surface, and then yep, we're adding that to point A. So that looks fine. That one looks fine. However, if that criteria isn't met, we're instead working at the distance to BC. So we're over CA, we're over BC. Using the BC normal. Okay, so at that point, we're over BC. Oh, hang on. No, that's right. We're over CA, and then we're over BC, which means that we must be over C if we're meeting both these criteria. So, getting the difference to C, comparing it to C, adding it to C. Dead simple, looks right. So that looks right. And then we've got finally the surface distance. So this is where we're over CA and we're under the surface. So, yep, we are dot producting that with the base and we're recalculating the difference. It doesn't matter whatever it happened to be previously, that's fine. And then, this is what we need to be careful with, because we've got the difference from C, and then we're dot producting with CA, and that looks fine to me. Okay, that's good. That one looks like it should be good. Okay, and then we've got this last block here, which might be the one that's broken, possibly. This is where we're not over any walls, but we're under the surface. So doing a dot product between the difference, and what's the difference here again? It is, just fold this up, it can't be any of this. Oops, can't be any of this. So it's the difference to point A. Okay, so yeah, we're getting the distance to the surface, and then we are adding the distance to the surface multiplied by the direction of the surface, which should project us onto the plane. Okay, that should be good. We're then getting the difference between that projected point and point B, and then we're comparing it to AB normal, which should give us the distance over side AB. And if we're over AB, okay, this is where things got a bit complicated and scary. We're doing a dot product with the edge coefficient, which should give us the unit interval of how far along the edge we are. So hang on a second here, just letting the old brain turn over a bit. So we're at point B, and we're doing a dot product with that normal, which should, but it's not actually a normal, but you know, give us the progress along AB, but backwards because we're sampling it from the wrong end. We then, oh, hang on a second. Hang on a second, we're clamping this to 0 to 1, and we're expecting to be -1 to 1, right? So we're actually going to want to add 1.0 to that, and then it's going to be A to B. Yeah, it's not BA, it's just inverse progress along AB. Actually, let's call it offset progress along AB, because it is going to be offset. Okay, that's that hopefully sorted. And then, sorry again, we're getting the distance to BC from the surface. So we've got our normal, sorry, our difference, which is, thanks for popping stuff up all over the screen, Visual Studio Code doesn't help. Hey, how's it going? I am getting very, very confused by collision code. I'm mostly just staring at it until my brain melts. Are you okay? Well, that sounds like an evening activity anyway. Oh, why is it doing that? Oh, yeah. So what we're trying to do here is we've got a we're giving it a point in 3D space, which is like the end of this like purple line, and we've got this triangle, and we're basically trying to sort of keep it within the triangle, and it's not really working yet. Like the white lines where it's ending up. Yeah. Especially when you've got a decision tree like this. The other thing I'm just going to check is, do I definitely have the right... Yes, I just want to make sure I didn't have like a really obvious, like, you know, something like that. Okay, so let's stop this advancing for now. Let's see if we can figure out which branch of this is actually broken, because it's going to be one of them, but we don't know which. So that looks right. Let's advance it along slightly to, say, there, and see where it ends up. That still looks right. That might be right, but I've got no idea. That one's wrong. Okay, there's definitely something wrong there, because it's starting kind of here, and then we're telling it to go over here, and rather than like clamping it to the edges of the triangle, it's just flying off into space for some reason. So, do I have the error header in here? Yes, I do. Okay. This is where we take every single branch and put a different error message in them and see which one it hits. If I had a debugger, this would be way easier. I could just step through it and see how it's getting through, but I don't have access to one really. Okay. Hopefully I don't run out of letters before I hit the bottom. That could actually happen. Ah, I think I've just spotted it. I think these are backwards. No, they're not. They're not. Ignore me. Okay, that... Oh, it didn't crash. That's interesting. Why didn't it crash? I'm just more confused. I don't think I caught every branch, did I? 'Cause I've also got stuff like these. Where did they get to, the letters? Where did they get to? Right, come on then. Which one are we hitting? What we got? We went to P. Okay. Oh. Okay. So how do we get to here then? This is where we're under the surface, but we're not necessarily actually colliding with anything. Ah, that might make sense actually. Okay, see if that fixes it. Of course, it's not going to fix it if I don't get rid of the error, but I shall leave those in. They could be useful later. That might be correct. It's a bit hard to say, but that might actually be correct. I mean, that does at least look like it's inside the triangle. It might be, because it can't quite tell from this camera angle whether that's kind of like close to us or far down and far away. Just going to reintroduce the code that sweeps it over the whole thing. Just actually put in a macro here. So I can quickly and easily disable this kind of logging. Okay, let's have another look at it. See if we can get this line to do something strange. Yes, I think that was right. Okay, next up. So it's kind of dragging down the wall, which is good. That's what we want. And then when it gets down to this corner here, it does something a bit weird where it kind of snaps to the back. So let's see if we can't get it to land there. A bit further than that, I think. A few more frames of advance. Okay, I think that's reproducing the issue. I think it is. So now I just put the error code back in, which I think is going to be like that. And it should. It went down F. It went down F. Where is F? F is there. Okay. Let's take this back out. So there's something wrong with this path. So all we're doing here, we have crossed over edge BC. Yep. And we've not crossed AB, we've not crossed CA, so but we have crossed the surface. So at that point, we are going to be along edge BC. And what is the difference here? It's the difference to point C. Okay. Yeah, I see. Yeah, we've got the same issues we had before where we actually need to subtract 1 from this. And it's an offset progress along BC. It's not like, I thought it was going to be the progress from C to B, not the progress from B to C, sort of take 1. So if I do that, that should fix it. That looks right. Okay, let's get it back into kind of like a sweeping mode and see if we can get to do anything obviously wrong. I'm going to speed it up slightly just so we can get to sweep through more of the more geometry before we can sort of call it. I think I might want to get the camera kind of sweeping around a bit so we can see a bit more clearly what's going on. I'm not convinced by the kind of like motion along this line. It looks a bit wrong. It seems to kind of like snap from one end to the other, which isn't quite right. So that's edge BC, which is just the code, we were just looking at. So the difference is it's the difference between the point we're currently working with and vertex C. We have the edge coefficient along BC. Now, it's also possible the code we have generating this is wrong. It's unlikely though. Okay, so we're definitely getting out of the array. That's good. And so we're at point C. We're kind of getting the offset. I wonder why that's wrong. So I guess I'm just going to check is how long are these edges? It's possible that there's something wrong with my maths. There it is. So they're all pretty pretty interesting lengths. So that should actually be good for reproducing strange bugs. Yeah, I'm not sure my solution actually works because that doesn't look terribly linear. Let's just adjust this so it's basically always on the floor. Yeah, it doesn't seem to be tracking along edge BC very well. Okay, next thing I'm going to do is I'm just going to look at the code for this and make sure, yeah, the code that actually generates that data that we're using and make sure that it at least kind of looks right. Here, this is our big stack of, yes, this is edge coefficient BC. Very calculating that. That looks exactly the same as every, yeah, that's so repetitive. I don't really see that being, I don't really see it being like the data's wrong. There must be something else wrong with this. So yeah, so we are getting the difference between the point we're sampling and point C, which is fine. Yep. And we're getting the dot product between the edge to coefficient and that difference, which should... I wonder if this isn't actually going to work. Because I was kind of assuming that if I did a dot product between a vector that was, say, a tenth of a unit vector, that it would basically give me like a unit vector scaled down by 90%. That might not be what this does. Let's just, for a bit of an experiment here, let's do something silly. This should place the point halfway along that line. Yeah, it does. So that appears to work. And if I put it at 0, it should, oops. Yeah, it puts it down there, and if I put it at 1, it should put it all the way at the other end, like that. So, okay, so something I'm going to try next. I'm just going to put this back to how it was. I'm going to check with the other one, because I just want to fix this in another... Oh, wait. It needs to be +1, not -1. That's why it's getting snapped to one edge. I think that might actually be working. It's a bit jank, but it is producing kind of plausible looking outputs. Okay, all right, okay. Let's reintroduce the movement on the y-axis and make sure it still does something reasonably rational. Again, it doesn't have to be perfect. It just has to do something that kind of follows, you know. This is basically a fallback, like a worst case scenario. Just watching this line, inspecting it, trying to make sure it does nothing too silly. I suspect when it's crossing this edge here, it's doing something a bit weird. Kind of looks like it's just skip forwards a bit and see if it's definitely doing something weird. I'm about to run out of time for today. I wanted to get this done. I wanted to get this done so I could start like actually getting some characters moving around. Okay, let's advance it slightly more. I want to leave this in a state where it's reproducing the issue straight away so I can, next time, just solve whatever issue is left. Okay, that's almost it. Actually, let's go into slow-mo. Let's go into like a real slow-mo and see if we can spot what's happening. Oh no, I think that's actually working. It's over both these edges, so it's kind of snapping to the midpoint. And then it's kind of backing this way. Okay, that looks a bit weird, but I think it's actually right. It does snap a bit, which isn't great. Not super happy with that. But it is at least picking like a point that's kind of close enough. Okay, that's actually working in that case. Well, I'm happy to leave it there. Thank you very much for watching. This was probably incomprehensible and honestly kind of annoying to watch. Have a great evening.